Let's go over some composite functions. So in what we've dealt with so far with functions, say for example f of x means that if we input a value for x, it's going to spit out a value f. So for example, we could say f of x equals 2x. So if we plug in, say, 5 for x, we'd say f of 5, right? So 5 replaces x equals 2 times 5. So when the value, or the function f of 5, when x is 5, is evaluated, it'll spit out the value 10, so twice times whatever x is. Okay, composite functions are similar, except, for example, for this one, we're looking for f of g of x. So typically, right, we're used to seeing just f of x. So if we're seeing f of x, right, this is the function f evaluated at x. Okay, the only difference from f of x and f of g of x is, see how this g of x kind of replaces the x? So what we're going to do is, we see that this function right here is g of x, this function right here is f of x, and both of them have x's in them. Okay, so what this means is, if this is typically f of x, but the x is replaced with g of x, right, it's the function evaluated at another function. So f of g of x, right, if f of x is 2x plus 1, and g of x is x squared minus 2x plus 1, right, everywhere we see x in the function f of x, we're going to replace it with g of x. Because we're not evaluating f of x, we're evaluating f of g of x. So g of x is going to replace the x that we saw before. So everywhere we see x in f of x, we're going to put g of x. So this is going to be 2 and not x, right? It's going to be 2 times x squared minus 2x plus 1. So instead of 2x plus 1, right, this is f of x. Right, it's going to be 2 times x squared minus 2x plus 1, and then plus 1 after that, because this right here really is our x, because it's not f of x, it's f of g of x. So I hope that makes sense. This is your answer for the first part there. And also we can expand this, so we're going to get, once we expand this 2 out, right, we're going to get 2x squared minus 4x plus 2, and then we're adding another one, so it's going to be 2x squared minus 4x plus 2 plus 1, so plus 3. So I'm going to write here, f of g of x is going to be equal to this side here. And another notation is just f and then a little o g. So it kind of looks like the word fog, except this o is really small. I don't know where the notation came from, but both of them are the same. So f of g of x equals f kind of dot g, like a little o there. Now, it's important to notice that this is not a linear transformation, okay? It's not reversible, so we can't go f of g of x, right, do what we just did, and say that's equal to g of f of x, because g and f are different functions. So now what we're going to do is the opposite. Typically, when we see g of f of x, we're used to seeing g of x, except instead of x, we see f of x. So now we're going to look at the function g, right? G is this function right here, and everywhere we see x, we're going to plug in what f of x is. So g of x, I'll write here, g of x is x squared minus 2x plus 1, right? And instead of writing x's, where we see that, right, we're looking at g of f of x. Okay, so this is going to be equal to, everywhere we see x, we're going to put 2x plus 1, because that's really our x, is our f. So 2x plus 1 squared minus 2x, and instead of x, I'm going to put 2 times 2x plus 1, because there's an x there, I got to replace it, and then plus 1. So I'm just going to expand this out quickly, right? 2x plus 1 squared, that's going to be 4x squared plus 4x plus 1, and then we got minus 4x minus 2 plus 1. So if we kind of combine like terms here, we're going to get 4x squared as our only x squared terms. And then we're going to get plus 4x minus 4x. Those are going to go away. Now we have plus 2 minus 2, or sorry, plus 1 minus 2 plus 1. So that is also going to go away. So all that we're left with now, right, the 4x's cancel, and then we got plus 1, then we're subtracting 2, so that's gone. We just get 4x squared, so that actually worked out. Now, this notation here, f of g of 2, notice how this is kind of like f of g of x, except the 2 is replacing the x. So to evaluate the function f of g of x when x equals 2, all we do is we take f of g of x in terms of x, and we replace 2 with it. So I'm going to write f of g of x here. Right, in part A, we determine that to be 2x squared minus 4x plus 3. Okay, so now f of g of 2, right, that's going to be, if we're evaluating it at 2, it's going to be 2 times 2 squared minus 4 times 2 plus 3. So everywhere we see x, now we're going to put 2. So now instead of replacing x with another function to make it a composite function, we're taking that composite function and evaluating it at an actual point, okay, at an actual true value. So this is going to be 2 times 4, so that's 8, minus 8 plus 3, so this is going to be 3. Okay, so f of g of 2 is 3. Now let's go g of f of negative 1. Well, g of f of x is just 4x squared. We determined that in part B. So g of f of x equals 4x squared, right? And if x is negative 1, right, we can just kind of plug that in for x. So it's going to be 4 times negative 1 squared, which is 4 times positive 1, so that's just 4. So your answers are 3 and 4 for that there. Now, this part right here, if f of x is negative x squared, and g of x is negative 5x minus 1, h of x is x, determine the composite functions f of g of h of x, g of h of f of x, and h of g of f of x. So these are definitely longer questions. I'm not going to expand all of them just for the sake of time, but what we would get is f of g of h of x is going to be equal to, so what we do first is we replace the x's in g of x with h of x. So h of x just is x, so g of h of x will just be g of x. Because if we replace the x's in g of x with h of x, it's still going to be an x. So this is really f of g of x, okay? And g of x is negative 5x minus 1, and f of x is negative x squared. So this is going to be negative 5x minus 1 squared, and I'll just expand this for you. So this will be 20, so I'll write the negative out here, negative 25x squared, and then we'll get negative 1 times negative 5, so it's going to be positive 10x, and then we're going to get plus 1. So this would be negative 25x squared minus 10x plus 1. Negative 25x squared minus 10x, and we're going to get minus 1. Okay, because we could always just factor out this negative here. So it would be negative 5x plus 1, and then all that squared. So it's really just 5x plus 1 squared. Okay, so this is f of g of h of x. Now, g of f of h of x, right? Remember, h of x is really x, so this is really just g of f of x. And remember, g is negative 5x minus 1, so this would be negative 5, and instead of x, I'm going to put f of x, which is negative x squared. And then we're going to get minus 1. So this will be positive, right, because it's two negatives, so 5x squared minus 1. That's g of h, or g of f of h of x. Now we're going to go h of g of f of x. So this shouldn't take too long, right, because h of x is just x, so h of g of f of x, right, if we replace the x's in g with f of x, right, we got g of f of x here to be 5x squared plus 1. or sorry, 5x squared minus 1. So this will be h of 5x squared minus 1, because remember, g of h of x we found here to be 5x squared minus 1. So if we replace it there, we're going to get h of 5x squared minus 1, and that's just going to equal 5x squared minus 1, because remember, 5x squared minus 1, that just equals 5x squared, sorry, minus 1 is going to be equal to x, right, because h is x, and we can just plug that in, and that's our answer there. So in my next video, I'm going to quickly go over this example, but that's kind of an introduction to composite functions. Thanks for listening.